Okay, welcome back. We're in section 6.1 on exponential functions. So we'll talk about those and a little bit on how to graph them. Primarily on how to graph them in this section. So let's start with what an exponential function is. It is a function, so f of x, but it looks like this. I have some number, we'll just call it a. A is just whatever, number 2, 3, 4. But the x is the exponent, right? So for example, I might have something like 2 raised to the x power. So it's the power now that changes, right? X can be whatever you plug in there. And this is an exponential function, right? So for example, if I had, let's call this g of x, just to differentiate it from my generic term up here. But if I say g of x equals 2 raised to the x, and I want to evaluate g of 2, that would be putting a 2 in for the x. So that's 2 squared, and that is 4, of course. So g of, say, 3 would be now 2 raised to the 3rd power, and that is 2 times 2 times 2, and that is 8. Right? And so we can plug in whatever values. G of 0, if we like, is 2 now raised to the 0, and recall that 2 to the 0 is going to be 1. Okay. So that's the basic idea of what an exponential function is, right? Excuse me. If I have some function, let's say f of x equals, let's say 3 to the x. Okay. And I want to evaluate some values, so let's say f of 1, f of 2, f of 5, right? Again, I'm just replacing the x in this expression with 1 or 2 or 5 or whatever's in there, right? So this would become 3 to the 1, but 3 to the 1 is just one factor of 3, so that's 3, right? F of 2 is 3 to the 2, or 3 squared. 3 squared is 3 times 3, which is 9. F of 5 is just 3 raised to the 5th power, which is 3 times 3 times 3 times 3 times 3, right? And you can see that these kind of get big pretty quickly. 3 times 3 is 9, excuse me, times another 3 is 27, times another 3 is 81, times another 3 is 273, I think. Yeah, that's right. Okay. What if I have, let's do one more here, let's do a couple more maybe. Let's go f of negative 2. What does that mean? Well, that is 3 raised to the negative 2 power. And so you'll recall that if I have a negative power, I can make it a positive power by taking this and putting it down into the denominator. So that's like 1 over 3 squared. 3 squared now is 9, so this is 1 over 9. F of negative 3 would be now 3 raised to the negative 3. But again, I'm just going to take that and put it in the denominator. 1 over 3 to the positive 3 now. The 3 to the 3rd is 3 times 3, which is 9 times the 3rd 3 gives you 27. And so I have 1 over 27. And of course, remember that f of 0 is 3 to the 0. That's 1. Anything raised to the 0 that's not 0 itself is going to be 1, right? So remember that. They don't always give you beautiful things, like we might have a fraction. Let's call this, let's do 2/3. f of x equals 2/3 raised to the x. So if I want to evaluate things like say f of 1, that's kind of dumb. That's 2/3 to the 1, but anything to the 1 is just itself, so that's 2/3. Right? But let's take a look at say f of 2. F of 2 is 2/3 to the 2. But again, that's a fraction raised to a power, so that's like the top getting squared and the bottom getting squared, and so that's 4/9. Right? Or it's like 2/3 times 2/3, which is still 4/9. Right? What about something like f of -3? Well, this is 2/3 then to the -3. And there's a few different ways you can deal with this, right? You can take this fraction and just flip it and change the exponent to be positive. Or you can distribute it and call this 2 to the -3 over 3 to the -3. But you can see these are going to flip anyway, so the 2 goes downstairs to make its 3 positive. 3 comes upstairs to make its exponent positive. And so I end up with 3 to the 3 over 2 to the 3, or 27/8. All right, let's graph one of these and see what they look like. Y equals 2 to the x, let's say. So if I'm graphing this, it's nice to have some values, right? So I'm going to plug in some x values and figure out what those y values are. So I'm going to plug in values like, say, -3, -2, -1, 0, 1, 2, 3, and we'll probably get a pretty good idea of what this looks like with those values. But if x is -3, y is 2 to the -3, which is 1/2 to the 3rd, which is 1/8. If x is -2, then y is 2 to the -2, or 1/2 to the 2, or 1/4. If x is -1, then I have 2 to the -1, which is 1/2, just 1/2, 1/2. If it's 0, I've got 2 to the 0, but that's just 1. If it's 1, if x is 1, y is 2 to the 1, which is just 2. If x is 2, then y is 2 to the 2, which is 4. If x is 3, y is 2 to the 3, which is 8. Right? And you'll recognize the pattern here. 1/8 multiplied by 2 is 1/4. Multiply that by 2, you get 1/2. Multiply it by 2, you get 1. Multiply it by 2, you get 2. Multiply it by 2, multiply it by 2, right? That's where this exponential, pattern comes from. It's multiplying it essentially by 2 every step in x, right? But I can graph this. If x is -3, y is 1/8. So let's call 1 right here. And if x is -3, y is 1/8, which is not far off of the x-axis, not very far up, right? If x is -2, I have y as 1/4, and so it's, a little bit higher. If x is -1, y is 1/2, so a little higher. If x is 0, y is 1, so I go through here. If x is 1, y is 2. So I go through there. If x is 2, y is 4. So I go up here. And this is where we start to kind of rock it up, because now we're doubling and we have bigger numbers to double every time. So when x is 3, y is 8, I'm already to the very top of my whiteboard here. Right? So what happens as it goes to the right is pretty obvious. It just whoop and goes up. So this is pretty clear. It'll do something like that and go on forever, right? Up, 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 as you try to go to the right more and more. But what happens to the left may not be as clear, right? As I come down here, do I just go down forever? Well, what's happening here? And the question is yes, or the answer is yes, I do go down forever. But another question, do I ever cross over the x-axis, right? So no matter how, if I keep going to the left, my negative numbers become negative, larger valued numbers, negative 10, negative 100, negative a million. But even if I were to try, let's say x is negative 1,000, right? Well, y would be 2 to the negative 1,000, but that's just 1 over 2 to the 1,000, right? 2 to the 1,000 is a huge number, and 1 divided by that is a very small number, but it's still positive, right? You'll never actually be able to get a negative number. I can say, well, what if we do go to 10,000 or 100,000 or a million, however big you want to make this number, it's still just going to be 1 over a really humongous number, but it's still going to be positive, right? It'll get very, very close to 0, right? 1 over 2 to the million, for all intents and purposes for us, is basically 0, but it's not actually 0. It's ever so slightly more than 0. So what happens here is I can get closer and closer and closer and closer, but I'll never get there, and therefore there's an asymptote here that I will never reach, but get super close to. And once you get past a certain point, as drawing this, it may as well be 0. But again, it's not 0. It's super close to it. Okay. But this is the graph of a generic, well, not a generic, but it's very specific, but most of your exponential graphs look like this, and this one happens to be 2 to the x. Let's graph another one. Let's graph f of x equals 1/2 to the x. Okay. And we'll we'll do the same thing that we did in the last one. I'm going to plop out some x values and figure out the y values associated with them. And those 7 values that I picked from the last one, from -3 to +3, are a pretty good starting point, right? If you can graph those, if you can see where the curve, starts to rocket up on a graph, then you're set. You should be able to do it from there. If not, you may have to make a minor adjustment, go further, more negative or more positive, but we'll see that happen in a minute. So I'm going to look at those 7 values. So if I have x is -3, y is 1/2 to the -3, which is the same thing as, you can just flip this fraction and call this 2 over 1, or just 2 to the 3, and therefore this is 8. If x is -2, I have 1/2 to the -2, which is, again, just flip this thing, so it's 2 to the 2, which is 4. And you can see the relationship here, right? 8 multiplied by 1/2 is 4. Multiply this by 1/2, you're going to get 2, which would make sense here, because I have 1/2 to the -1, which is 2 to the 1, which is, oh, surprise, it's 2, right? Once you recognize this pattern, you can actually dump the algebra and just go with the pattern. 8, half of 8 is 4, half of 8 is 2, half of 2 is 1, which makes sense because anything with a 0 is 1. Half of that is 1/2, half of that is 1/4, half of that is 1/8. And you'll note that this is just the last y values we got from 2 to the x flipped, right? We had 1/8, 1/4, 1/2, 1, 2, 4, 8. Now we've got them all in the opposite order, right? So if I go to graph this one, if x is -3, I have 8, so I'm already starting pretty high. If x is negative 2, y is 4, so we'll just call it there. If x is negative 1, y is 2. If x is 0, y is 1. If x is 1, y is a half. You can see I'm just carving out the same path, except instead of coming off the asymptote from the left and going up, I'm diving down now, and then we'll approach the asymptote as I go to the right. X is 2, y is a quarter. X is 3, y is an eighth. If x were 4, y would be 1/16, right? So it just gets closer and closer. If x is 5, y is 1 over 32, or 1 over 32. They're just smaller and smaller and smaller. And therefore, I carve out the path. Looks more or less like that. Okay. All right, let's take a look at another one. Let's graph. Let's say g of x equals 3 raised to the x plus 4. Right? So now my exponent is not just a simple little x, it's an expression. It's x plus 4, right? And so if I go through the same process and I say I'm going to pick my x values like I've been picking them, let's say x is negative 3, negative 2, negative 1, 0, 1, 2, and 3, right? Which is not a bad place to start. But we'll see where it goes kind of not helpful in a minute. So let's just plug these in. If x is negative 3, y is 3 raised to the negative 3 plus 4 power, right? Well, that's 3 to the 1, and so that's 3. Right? If x is negative 2, then I have 3 to the negative 2 plus 4, but that's 3 to the 2, and that is 9. Right? Now you can see the pattern already, multiplied by 3, multiplied by 3, multiplied by 3, with every increase of 1 in x. If x is negative 1, then I have 3 to the negative 1 plus 4, but that's 3 to the 3, which is no surprise, 9 times 3 is 27, so I should get 81, and it starts to become very unhelpful because I'm not going to draw my graph big enough to throw an 81 on here, or a 273, or a that seems wrong. It is wrong. I don't know what that is, but it's big, right? But they're really big. This ends up being 3 to the 4, 3 to the 5, 3 to the 6, whatever that is, and 3 to the 7th. And those are huge numbers. I'm not going to graph with these ginormous numbers. So anything past 0, to me, is not particularly helpful. I just know that it blows up, right? So I should probably get some numbers on the other side. I should shift and say I need to know what x being negative 4 gives me, and negative 5, and negative 6. But again, we can graph this without that, just with what we know so far. I've got a couple values. If x is negative 1, y is 27, so that's on the ceiling. If x is negative 2, y is 9, so I'll just say that that's up here somewhere. If x is negative 3, then I have y is 3, so I take that dump. But then if I keep going, I'm just going to be dividing by 3. So at x is negative 4, I'm at 1, and then I'm going to erase these values just so I can continue my graph here. If x is negative 4, I should be at 1, and then if negative 5, I should divide that by 3, so I should be at 1/3. It's hard to graph when I can't even get a straight axis here, but I hope you get the point, right? 1/3, 1/9, 1 over 27, and so on and so on. I asymptotically approach there. But the point is that I still have this skyrocketing behavior, but it's essentially just been shifted to the left, right? Normally I would have something that crosses over 0, 1, and then increases over here. But it's all been dragged to the left by 4 places, right? And so we recognize that it's just the same thing, it's just been shifted to the left. All right, I think that covers it. Thank you, and I will see you guys for the next one.